Hi everybody, thanks for coming. I'm really excited to stand here in front of you and speak. Today I'm going to speak about backend testing of microservices platform. And I'm going to show a bit of code, and you can find it on the GitHub and check it in a parallel with me. So let's start. And several facts about myself. So I have been working in the QA industry for 8 years. And during this time, I have faced different platforms, like IPTV, e-commerce platform. And nowadays, I'm working in Berlin company, BitPlaces. And we are doing location-based services and mobile marketing based on geofencing and beacon ranging. And we do a lot of analytics under the hood and machine learning. And my expertise is distributed from the backend testing to the mobile testing for the both platforms. And I like automation because I want to help to deliver functionality faster, to make developers to have a quick feedback on their changes, and to let them deliver their functionality. Today I'm going to talk about exact use cases I have solved during my testing of microservices. And let's talk from the first one. The first one is about a problem of maintaining the huge number of HTTP clients. As far as you have a lot of services nowadays, you have a lot of clients, and it's very expensive to maintain everything. It's error-prone, it can waste Jenkins time, because your clients can be outdated, you can check something irrelevant, and that's it. So the solution in this case is quite intuitive. You have to generate your HTTP clients based on developer code. And it will solve at least two problems simultaneously. So first of all, QA team will always have up-to-date HTTP clients. It will be with zero efforts from QA team. And from the other hand, developers will also have these clients, and they can use it for communication between their services. And as a solution, we have chosen Swagger. It's based on OpenAPI specification within, so you can describe your services using this specification. And let's see the major step, how generation happens. So first of all, developers annotate their interfaces with special Swagger annotations. Later, Swagger, based on these annotations, generates the JSON file where within the OpenAPI specification, the interface is described. Later, Swagger, based on this JSON, generates the source code of the client. Swagger can do it in many languages. In our case, it's Java, and so in our case, we have finally Maven project with source code for the client. And the last thing you need is just to build the artifact and upload it to the Nexus. And Swagger provides two ways how to do it. You can use a command line way of generation, or you can use a Maven plugin. So we have tried both approaches. We have started from the command line, but later we switched to Maven way of generation. So here you see how it looks in developer's code. For these reasons, I have created the very simple Spring Boot application with simple API, just to show how Swagger annotations are used. So here you can see that API annotation, API responses, this is used to describe with metadata your interface. You specify the nickname. This will be used for name inside the client. You specify the response type, you specify the response codes, and so on. Then, when everything is generated and QA team is ready to just include clients as dependencies, you're ready to start and call. And in my project, I have implemented the special layer to call everything what is related to HTTP. It's from one hand it's Swagger, from the other hand we have some kind of custom client, but mostly it's Swagger. And why this abstraction? I need this executor level to abstract over the HTTP calls, and so to put some additional steps nearby. So I want to put some logging. Sometimes I need to cache the result and to introduce a mechanism of exception verification. So finally, I want to hide all the logic and just expose the convenient API of the executor. And as far as I have started to talk about my architecture, let's move further. My project is based on Cucumber JVM plus Spring. And besides the core parts of Cucumber JVM, like feature files, step definitions, and hooks, the rest of my code can be roughly divided into 4 parts. The first one is executors. Everything for HTTP calls is hidden inside these executors. The second part is checkers. So checker is a class which contains of methods for particular object verification. This is just for convenience, for structuring. So the checker for user object, the checker for event object, just structuring. The next bucket is DTO providers. So client methods accept DTOs as an input parameters. And sometimes it's a real big DTOs with a lot of fields. And you also have to have convenient API to build such kind of DTOs. And so, for example, to have them method to briefly provide the object with default values of the parameters, and so on. Just convenience for building objects. And the last bucket is some kind of utilities. So this is all classes for dealing with variety of storages, for cleaning up, like classes to extend Cucumber, and helpers, so everything. Let's go through the code briefly. So this is so let's start from the checker. As an example, this checker is responsible for checking user object. So here you can find only one method, but within the same way you can put here another methods. And so it's convenient to keep everything in one heap per object. The next bucket is executor. So actually there are a lot of executors, but here's only one example. You can see the hidden Swagger client, and this is the final API of executor, pretty straightforward. But underneath you have a logging. Here you can put the caching. Here you can introduce a mechanism of exception verification, and so on. Everything is hidden. And DTO provider. Here I provide user DTO. The way how I do it, usually in a Cucumber, I just provide, when I have a lot of input parameters, I enumerate them within the k-value approach. And when I ready to build it, I provide the DTO which I want to build and list of these k-value pairs. And then in a switch case manner, I check the k and set the value. And finally, I get this DTO. And the important part, so why do I abstract all of this DTO creation, executors? Because in step definitions, I don't want to put the logic. I just want to take input parameters, build DTO, here's it, and execute the call. And nothing more, only abstraction. So what benefits do I see in such kind of architecture? For the code is more or less clean, structured, and easily extended. The second, so I really pay a lot of attention to this executor level because it helps me a lot. The next, potentially, if you have a real task sometimes to switch to another framework, for example, to testng, it will not be a huge pain to do it because you don't have a logic inside step definitions. You are not very connected to Cucumber. You can move to another framework. And the last, the usage of these executors. So you can not only use it in step definitions, you can also use it in the hooks when you prepare the data. You can also use this convenient API to like briefly build the messages, events. Such kind of hooks are very well readable. The next use case. So as far as I'm dealing with microservices, it means that the environment for my regression testing is quite big. And you usually can face the situation when some service is deployed incorrectly, or it can be even not deployed. But you want to you want to control the situation. You just don't want to execute your tests on something. You just want to be sure that everything you need is deployed and deployed correctly. In this case, the solution is also quite intuitive. So as far as all our microservices are built on Spring Boot, it means that Spring provides out-of-the-box health check service. For us, the goal sounds like we want to periodically call this service for all necessary microservices and verify the result. And to make it in a separate thread, just to let it be somewhere. And in case you have a problem, you just give up the execution, free up resources, and next job will be executed. And I will show you two implementations of this approach. The first one is tightly coupled with Cucumber JVM because you extend the Cucumber runner. So as you remember, so Cucumber JVM is just implementation of runner, of JUnit runner. And in my case, I even more want to extend it. And at the point when Cucumber JVM starts the execution, I want to start my thread with checks. Let's see how it looks in code. There is a branch, health check. And here is it. So this is a Cucumber component implementation of runner. I extend it. And at the point when Cucumber starts the execution of the tests, before it, I start my thread. What's inside? Inside is just the scheduled executor service with one thread. And this thread executes the runnable. And this runnable is just the in the loop, I perform the GET requests to the health service of all microservices, and then verify the result. If something goes wrong in this case, either the service is not responsible at all, is not responding at all, or the health is not good, I use run notifier, here is it, to stop test execution. Run notifier is also the component of Cucumber JVM, which is responsible to notify all listeners that events like test is started, test is finished, is ignored, happens. So let's go to the second implementation. The second implementation doesn't depend on testing framework. It's based on Spring Task, and it's implemented almost with the same things, but so first of all, you need to switch on the Spring Task in your application context, and then you have to create this Spring Task, and here is it. You like put the Spring annotation, specify the period of repetition, and inside it's pretty much the same. You also use this executor service with one thread, the same runnable, the same idea under the hood, but in this case, when there is a problem, you just use system exit 1, because in this case, you cannot reach the run notifier. So as a summary of this approach, I can say that failing fast based on state of environment, I have saved a lot of Jenkins time, and I didn't create an unnecessary queues of the jobs. The next use case is about usage of before hook. It's well known that Cucumber doesn't provide out-of-the-box implementation of before feature hook, like hook which will be executed before set of tests. In my case, even more, I want to implement following situation. I have a feature with set of scenarios. And first of all, I want to prepare data for all of them, and I want to do it only once, and it will be good, but like the third scenario, what if I want to put it inside already in the middle of like existing scenarios, and I want to prepare particular data for this scenario. And I don't want to break the test data for fourth scenario. I want fourth scenario to later prepare data again. So yeah, if you check the internet, you will find the like common solution of implementing before hook. It's based on static Boolean flag in the hook, but it will be executed only once. It doesn't satisfy my needs. In my case, I went a bit further, and I have extracted this field out of the hook, put it inside some kind of holder, and made it string to have more values. And currently, the business logic of decision making looks following. So here I have this hook holder, not hook, but flag holder, and the idea is that each hook has an associated flag. And when Cucumber wants to execute a hook, it takes the flag of this hook and compares with the flag from the previous hook. If flags are similar, then hook is not executed. Like I want to try to execute the second hook, the green one, for the second time. But after the second hook is the green, the blue one is executed, I'm able to execute first hook again. So that's the case. So I execute the hook for fourth scenario again. So this behavior already satisfies my needs, but there is another one detail. What if I have a hook in the beginning for set of tests, everything goes well. But let's imagine that one of the tests in the middle modifies the data. And it's okay, I'm good with it, I have an intention to do it. But there is a risk that these changes will break results of further tests. It means that for me, I want to implement following picture. Okay, I have this seventh test which modifies data, but I want to make sure that the eighth test will run hook for himself again. And I have implemented it using after hook, also provided by Cucumber. And in this after hook, I completely reset this shared flag. So currently, when I'm done with this implementation in my project, I don't have flaky tests because of mess of the test data. It's quite predictable what to expect. And yeah, I'm quite satisfied with it. The next use case is about cleaning up of the data. Again, I have a lot of microservices deployed on my environment for regression testing. But what if my test checks only subset of these microservices? I don't want to clean up all the things everywhere. I want to clean storages only for this subset of microservices. What prerequisites do I have in this case? Of course, I can accurately put in each hook what storages to clean. But this is unmaintainable behavior. Instead of it, I propose to have a command step delete all for all hooks. You just put it, and you will be sure that everything will be cleaned under the hood. And provide the implementation of to choose what to clean already in this command step. And how to make this decision. So each my test in the project is annotated, is tagged by what microservice does it test. It means that, so I can easily filter out the scenarios for particular microservice. And at the same time, I can take this tag, move it to this delete all step, and provide some logic to choose what to clean up in this case. So this is implementation, how I did it. I again extend a bit the Cucumber framework. So I extend Cucumber runner. Inside, I have a method create runtime, which creates runtime. Runtime is a component of Cucumber which is responsible to running steps and hooks. It means that if I extend a bit the native runtime by my own, I can intercept execution of method run before hooks and catch the tags which were connected to the scenario. So and I take this text and use it inside the delete all method. Let's see in code, it will be easier to understand. So yeah, this is my extended Cucumber runner. I override the method which is responsible for creating runtime, but instead of runtime, I provide my own, which is just extension of normal runtime. And I override the method which is responsible for starting hooks, especially before hooks. And I catch these tags, store them in some kind of holder, and in CleanExecutor, when I'm ready to clean some abstract data, I make a decision. So I make the tags, and in which case manner I make a decision based on what annotations, what tags I have, what to clean. So let's see some demo. I have a very simple feature and one scenario. It doesn't matter what's inside. The important things is tags. So these are tags which mark what do I test within this test. API component, BM component, TM component, and here is like normal before hook. Normal before hook. Here is it. And yeah, I have this delete all abstract step. And inside of it, I have gotten this API, BM, TM tags at this point, and I make a decision that I'm going to clean Cassandra, MySQL, and so on. And then let's run this. And you will see that I'm catching the tags. I'm catching the tags, and I'm cleaning only particular storages. What if, for example, so my feature doesn't test any more API. So I don't need to clean maybe some storages. Yes, that's right. Currently I'm cleaning only 2 storages instead of 4. So when I introduced this approach in my project, I have saved a lot of time in test execution because I stopped cleaning everything everywhere. I cleaning only particular stuff. So the next use case is about mocking, like special usage of mocking. As far as we're a location-based company, we send push notifications to mobile clients. And once our customer said, so we want to send pushes by ourselves. Okay. It means that we have a third-party component inside our integration loop, and we need to test it. And personally, I wanted to test the whole integration. Of course, I could divide it into parts and test everything what happens before, everything what happens after, but I want to check the whole loop. For these reasons, I created a mock. Basically, I created the Spring Boot application, which, so let's see the implementation. When system is ready to call the third-party component, instead of it, it calls my Spring Boot application. On the first stage, I check that we call third-party component correctly. I check the schema of the request, the internals of the JSON, that everything is okay, we call them correctly, and later, when I'm sure, I send push notification to the mobile client by myself. So as far as I was called by our component, I can build the push notification by myself because I know the internals. I send it, and in this case, customer was sending push notification with a bit different manner. It means that I also send it in this way, and I check that mobile client is ready to accept this new version of message. So this approach is not widely used. we just had this use case. We thought about it, and we decided to implement this approach. It was the first time for us, and we were pretty satisfied. So you can find an example of it in GitHub, how it's implemented. And the last use case is about creating test data, which is distributed in time. What's special for me in this case? We have an event-based system. It means that I cannot just create test data like directly inserting SQL, like using SQL statements to upload data to MySQL and to Cassandra. I cannot do it. I can use only externally, like system API. And for example, when I initiate an event, a lot of stuff happening under the hood, and a lot of storages are involved, and it's just very complicated to follow what to put where to prepare the data. That's why I use API, and it's not a problem for me. The problem is that we have an analytics component in the system, which is responsible for gathering statistics, how many messages we sent, how many events, how many messages we read, and so on. And this component provides the reports like per month, per week, per hour. Yeah, we need the data which is distributed in time. And the solution in this case is following. All our microservices are deployed as a Docker containers inside the same VM. And what we did, so we have created another one microservice, put it inside Docker, and also deployed to the same VM with a root permissions. And what's going on this? This microservice has an API like set date and reset date. And under the hood, it just invokes Linux command date with a parameter, and that's it. It was our first idea how to deal with this problem, and fortunately, it worked out. So currently, we can create this distributed test data. So really complicated scenarios with different events in different period of times. And yeah, it was one problem that we have schedulers provided by Spring, and they doesn't work. But all the other things works with this approach. Once again, so that's it for today. You can find every examples. I think no example for time machine for the last use case, but you can find all other examples on the GitHub, and you can reach me later and ask all the necessary questions. So thank you very much.